So Argand diagram is basically the complex plane. So previously we had the y-axis and the x-axis, but now the Argand plane has the real axis instead of the x-axis, and on the y-axis we have the imaginary axis. So say using the same example, 3 plus 4 iota. If I have to sketch this, so 1, 2, 3. 3 is the real number, and 1, 2, 3, 4. This is 4 iota. So this will be somewhere over here. This is my point, and if I extend the line, so this is what the line would look like, right? So let's talk about the modulus. So modulus is basically the length of a complex number. So to find the modulus, you basically square the real and imaginary part. This means 3 squared plus 4 squared, whole thing under root. So 5 is the modulus. This means that the length of this modulus of the complex number is 5. So this over here is 5. Then let's talk about the argument. So the argument refers to the angle that's created with a horizontal when you plot a complex number. To find the argument, tan inverse of b upon a, so theta will be 53.1 degrees. So this angle over here is theta equals to 53.1 degrees. Then let's talk about the principal argument. So the principal argument always lies between minus 180 to 180 in degrees, and from minus pi to pi in radians. So this was where both the imaginary and real parts were positive. Let's say we had minus 3 plus 4i. So this will be in the second quadrant. So this, let's say, sketching it roughly, this is minus 3. Let's say this is 4i. So this point over here is my complex number minus 3 plus 4i, and if I extend this line from the modulus, from the origin, the modulus will remain the same, 5. However, theta will change. The argument of this complex number will change. So the argument, so the angle tan inverse of 4 upon 3 is 53.1. This means that this angle is 53.1, but the argument is this part. So the argument of this complex number will be 180 minus 53.1. So the argument of this complex number will be 126.9 degrees, right? Because this part is the argument that it makes from the positive real axis. Let's do another example. Let's say the complex number was minus 3 minus 4i. So this means it's in the third quadrant. So this over here is minus 3, and let's say roughly this over here is minus 4i. This is my complex number. The modulus again will remain the same, it's 5. However, this angle is theta, that's 53.1. But the argument will now be this region. This region is your argument. So this angle, basically, let me use a different color. This angle highlighted in yellow will be 126.9, but we said that the principal argument is always from minus 180 to plus 180. So if I am to write the argument of minus 3 minus 4i, so argument of this z will be minus 126.9 because if I mark the angles, so this will be minus 180. This would be minus 90, this would be 0, and then 90, and then again 180. From minus 180 to plus 180. The modulus will remain the same, 5. So modulus is 5, but the argument changes based on where the complex number lies, in which quadrant particularly the complex number lies. The last one is, let's say, (3 minus 4i). This means that it's in the last quadrant. So roughly sketching this is 3, this is minus 4i, this is where the complex number lies. Sketching the line. So the modulus will remain the same, right, and it's this angle, that's theta, but it's also the argument. So the argument of 3 minus 4i will simply be minus 53.1 degrees. So if you want to know where the modulus and argument comes from, so we said this is 3 and this is 4i. So this is your complex number over here. If I extend these lines, so this will be 4, this over here will make a 90 degrees angle, this will be 3, right? And this over here is the modulus denoted by r. So the modulus is, by simply using Pythagoras theorem, modulus is simply root of 3 squared plus 4 squared, which gives me root 25 and 5. And if I talk about the argument, so to calculate theta, I can use tan. So tan theta equals to opposite upon adjacent, so 4 upon 3. So theta equals to tan inverse of 4 upon 3. So this means that if I say that z equals to a plus bi, so the modulus is simply root of a squared plus b squared. And the argument is tan inverse b over a. And then based on the quadrant you decide whether what the argument would be based on the principal argument, that is, it needs to be between minus 180 to 180 unless otherwise it's stated in the question. So this is all about the introduction to the Argand diagram. In the next video we'll talk about the different forms of equations of complex numbers, and then we'll move on to the loci that we have to sketch in the papers through using Argand diagram.